This is the story of how the sea otter, one small marine mammal hunted to the edge of extinction along the California coast, turned out to be the single species holding an entire ocean ecosystem together, and what happened to that ecosystem during the century, it was gone. The California coastline today supports kelp forests, thriving fish populations, healthy estuaries, and some of the most biodiverse shallow marine habitat on the Pacific coast. Most people assume that is simply what a healthy California coast looks like. For most of the last 100 years, it was not. Large stretches of that coastline were collapsing, urchin barrens where kelp forests once stood, eroding marshes where seagrass once anchored the shore, and an invasive crab population spreading unchecked through one of the state's most consequential estuaries. The recovery did not come from conservation programs or government intervention or marine restoration projects. One animal came back and did what it had always done: eating. Before European and Russian ships began working the California coast, the worldwide sea otter population numbered somewhere between 150,000 and 300,000 animals, ranging from Baja California across the entire Pacific Rim to Hokkaido Island in Japan. The southern sea otter, Enhydra lutris neris, the subspecies found along the California coast, had a pre-exploitation population of approximately 16,000 animals. That is a lot of otters. And otters, it turns out, are not simply residents of a coastal ecosystem. They are architects of it. The mechanism is straightforward, and among the most well-documented examples of what ecologists call a trophic cascade. Sea otters eat sea urchins, primarily the purple sea urchin, Strongylocentrotus purpuratus, and sea urchins, when their populations run without a predator to check them, eat kelp until almost nothing remains. Places overrun with urchins carry the name urchin barrens, which describes exactly what they look like. With otters present, multi-layered kelp forests develop, and those forests support dozens of algae and animal species that depend on the structure for feeding, shelter, and breeding. Remove the otters, the urchins multiply, the kelp disappears, and what is left is a flat, stripped seafloor. For thousands of years, sea otters kept that balance intact along the entire California coast, and that's when the fur trade arrived. Sea otter fur is the densest of any mammal on Earth, and in the 18th and 19th centuries, that density made it worth extraordinary sums on European and Asian markets. What followed was one of the most thorough commercial wildlife slaughters in recorded history. Across their entire Pacific range, the maritime fur trade killed approximately 1 million sea otters. Along the California coast, the numbers are specific and worth sitting with. From 1803 to 1805, in just 2 years, over 17,000 sea otter pelts came out of California waters alone. The Russian-American Fur Company, across 35 years of operations along the California coast, took over 100,000 pelts, 100,000 animals from a single stretch of coastline by a single company over 3 decades. By the early 20th century, the California sea otter sat at functional extinction. A population that had once numbered 16,000 animals along this coastline had been reduced to a number so small that most biologists assumed the species was simply gone from the state. And without the otters, the coast began to change. Urchin populations expanded without predation, kelp forests thinned and in many areas collapsed entirely, and the structure of one of the Pacific's most productive marine ecosystems started to unravel, slowly and largely, without anyone noticing, because within a generation the collapsed state had become the new normal. Spring of 1938 brought something nobody expected. A couple driving along California's newly completed Highway 1 spotted dark, buoyant forms floating below the Big Sur cliffs. Marine biologist Rolf Bolin from Stanford University confirmed the sighting on March 25, 1938. A colony of approximately 50 sea otters, alive and apparently thriving in a remote stretch of coastline south of Monterey that fur hunters had somehow missed. On June 20, 1938, Life magazine ran a photograph of the colony under a headline that captures the shock of the moment. The extinct sea otter swims back to life. Every sea otter alive in California today descended from that colony. 50 animals on a remote stretch of Big Sur were all that remained of a population that had once numbered 16,000 along the California coast, part of a worldwide range holding up to 300,000. Legal protections followed immediately. and through the mid-20th century, the population began its slow recovery. By the 1980s, sea otters had started moving along the coast, recolonizing habitat they had been absent from for a century. The question nobody fully understood yet was what their return would mean for the ecosystems they moved back into. As otters returned to stretches of the California coast, researchers began documenting something that changed the way ecologists think about predator recovery. At sites recolonized by otters, seafloor communities transitioned from urchin barrens to kelp forests so quickly that they effectively toggled between two distinct states across annual surveys. The change was not gradual, it was rapid and driven by one thing: the otters eating the urchins. The carbon numbers tell a story that goes well beyond ecology. Where otters are present and kelp forests develop, net primary productivity runs between 313 and 900 grams of carbon per square meter per year. Where otters are absent and urchin barrens dominate, that figure drops to between 25 and 70 grams. Across their North American range, the effect of sea otter predation on living kelp biomass represents an increase in carbon storage of between 4.4 and 8.7 teragrams. That's 4.4 to 8.7 million metric tons of carbon. The kelp forests that otters enable are functioning carbon sinks, fish nurseries, and biodiversity hotspots. And without the predator keeping the urchin population in check, none of that exists. The science is more nuanced than a simple chain. Some researchers point out that larval dispersal, oceanographic regimes, and recruitment patterns influence urchin populations in some areas as much as predation does. The Trophic Cascade is real and well documented, but coastal ecosystems are complex, and the otter is one powerful factor among several. Acknowledging the complexity is what separates honest science communication from oversimplification. The kelp forest story is the one most people associate with sea otters. What happened at Elkhorn Slough, documented in research published in early 2024 by Brent Hughes at Sonoma State University in the journal Nature, adds a completely different layer to what otter recovery means for the California coast. Elkhorn Slough is one of the largest estuaries in the United States, and for decades it was deteriorating badly. After fur hunters removed otters from the salt marshes, lined shore crabs, burrowing into the banks and destroying the seagrass root systems that hold the marsh together. The banks eroded, the seagrass died, the estuary lost ground at a measurable rate every year, and that rate accelerated as the crab population grew without any natural control. Today, Elkhorn Slough holds the highest concentration of sea otters in all of California, approximately 100 animals in a single estuary. Researchers ran a controlled experiment comparing plots where otters foraged freely against caged plots that kept otters out. Without otters, crab numbers stayed high, burrows multiplied, and vegetation declined. Where otters fed freely, they ate the crabs, burrows filled in, marsh banks solidified, and seagrass recovered. The result was that otters were preventing approximately 10 inches of salt marsh loss per year. Marine sustainability scientist Lakeelia Jenkins at Arizona State University put the wider implication plainly. Sea otters go from just a cute thing we like to have around to something that can protect our livelihoods and our properties. Healthy salt marshes reduce flooding, protect coastline, store carbon, and buffer storm surge. One animal controlling one crab population generates benefits that extend far beyond the estuary itself. December 2024 brought a second Elkhorn Slough study that added yet another layer to the story. European green crabs, Carcinus manus, rank among the most destructive invasive species in coastal marine environments worldwide. First detected at Elkhorn Slough in 1994, their population peaked in the early 2000s as they spread through the estuary with no natural predator to slow them down. Nobody had designed a green crab management strategy around a marine mammal. But when researchers examined the data, the pattern was unmistakable. As the sea otter population at Elkhorn Slough rose, the invasive green crab population declined, and investigators calculated that the current otter population consumes up to 120,000 green crabs per year. The otters had been controlling an invasive species crisis that marine managers had not solved, not as part of any conservation program, but simply by eating what was available. This is what Keystone species do. Their effects ripple outward in ways that take years of careful research to fully map, and each new study adds another layer to what the presence or absence of one animal means for an entire coastal system. The current California sea otter population sits at approximately 3,000 animals, ranging from Monterey Bay to the Channel Islands off the central coast. From a colony of 50 survivors near Bixby Creek in 1938, the population has grown to 3,000 across roughly 80 years of legal protection and slow natural recovery. That is a genuine conservation success by any measure. It is also an incomplete one. Southern sea otters retain their status as a threatened species under the Endangered Species Act, with shark bite mortality, range limitations, and the accelerating pressures of climate change continuing to constrain the population. The recovery is real, and the trend is positive. But the species is not secure, and the coast that could benefit from more otters extends far beyond where they currently live. In 2021, Congress directed the U.S. Fish and Wildlife Service to assess the feasibility of reintroducing sea otters to portions of Northern California and Oregon, where they once ranged. That assessment concluded reintroduction was biologically feasible and could generate significant benefits for both sea otters and near-shore marine ecosystems in those regions, potentially expanding marine protected areas and kelp forest restoration efforts. The reintroduction has not happened yet. North of the current range, the coast still sits without the animal that once structured it. Its urchin populations unchecked, its kelp forests under pressure, waiting on a decision that the science has already supported. Vancouver stopped mowing its parks and bee species doubled. The Klamath dams came out and salmon returned within days. Bison came back to tribal land and the prairie started rebuilding itself. The sea otter story fits that pattern exactly, and it adds something the others do not have quite so clearly documented. The California coast did not need engineering. No restoration program designed the kelp forest recovery. No government initiative targeted the green crabs at Elkhorn Slough. No conservation grant solidified the eroding marsh banks. One animal returned and did what it had always done, and the ecosystem responded to every part of that return in ways researchers are still mapping nearly a century later. What makes this story sit differently from a simple wildlife comeback is the scale of what was lost and how little most people knew it was gone. The California coast that generations of people grew up thinking of as natural and healthy was a diminished version of itself, operating without a keystone species that had shaped it for thousands of years. The 3,000 otters alive today are doing ecosystem restoration at a complexity and scale that no human program has matched along that coastline, on less than 2% of the historical population. North of the current range, the coast is still waiting. The question the research now asks, plainly and without ambiguity, is what it would look like if the animal came back there too. Sea otters are one of the few animals known to use tools. They carry a favorite rock with them, stored in a skin pouch under their arm, and use it to crack open shellfish on their chest while floating on their backs. They hold hands with their pups while sleeping, so they do not drift apart. They wrap themselves in kelp to anchor themselves in place overnight. They are also, as it turns out, one of the most effective coastal restoration forces on the Pacific coast of North America, and the California coast spent the better part of a century demonstrating in measurable and documented detail exactly what it costs to lose them. The comeback is real. The population is growing. The science on what their presence means keeps expanding with every new study. And north of their current range, the coast is still waiting. Rewilded covers stories like this, nature coming back in places people least expect it, backed by real research and real numbers. Subscribing takes 2 seconds and it genuinely helps the channel grow. Drop a comment and tell me what surprised you most about this one. I read every single one.